it seems that everything needs GNSS nowadays. So, how do you legislate for that? How do you govern for it? Or how do you create a sovereign stack from consumer to the satellites in space? How do you do that? It's a very difficult question to answer, and I don't think it's possible, quite frankly.
On this episode of Embedded Insiders, the CEO of Qualynx, Tom Trill, joins the podcast to discuss GNSS and sovereignty. We're talking about revolutionizing GNSS with an ultra-low power, high performance, reconfigurable positioning and location chip designed to challenge conventional GNSS chip architectures. Then, Rich and Rod Cope, the Chief Technical Officer at Perforce Software, are discussing how to employ AI for code development and whether you should use AI to generate code or just limit it to code review. Hello, everyone, and welcome back to the Embedded Insiders podcast. I'm Assistant Managing Editor Tiara Oliver, and this week I'll be taking over the intro alone, as Ken is in Taipei for Computex 2026, but he will be back next week to give us a recap of the event. In the meantime, I wanted to share some information about the upcoming CRA virtual conference hosted by Embedded Computing Design, featuring some very prominent sponsors and leaders who will be covering the topic of cybersecurity compliance for embedded engineers. The event does take place on Thursday, June 25th, and registration is open now. So be sure to check the link in the description of this podcast for more information and to register for the event. And we'll see you there. Now, here's Tom Trill of Qualynx.
Thanks, Tiara. Sure, pleasure to be on. And thank you very much for the opportunity. My name's Tom Trill, and I'm the CEO of Qualynx. Qualynx is a RF company. More specifically, we're a digital RF company, and we effectively transition about 90% of an RF analog receiver to digital. And because of that capability, we can migrate RF back in line with Moore's Law and avail of all of the advantages of CMOS scaling, where much of the legacy technology is, in fact, hitting the scaling wall. So that's the fundamental novelty that we have here at Qualynx. We've been operating and scaling for almost the last 4 years and about to launch our product into mass production for the market.
Awesome. So I know a bit of what we're talking about today is GNSS sovereignty. For those who may not know, when you use the term GNSS sovereignty, what does that actually mean for, device makers, governments, and the end user?
Yeah, it's very topical and very complicated. And by no means is it easy to solve for or easy to ultimately assure or institute or police GNSS sovereignty. So no matter what angle you look at it from, whether it's from the legislative or even the environmental angle, the commercial angle, the supply angle, having sovereign GNSS is incredibly difficult. There are basically 6 constellations of satellites that comprise of the entire GNSS system. GNSS means Global Navigation Satellite System, and the most common and the original of those constellations is GPS, which is American owned and operated. The European constellation is called Galileo. Owned and launched into space by the European Space Agency, and then their services which they offer from that constellation are managed by the European Union Space Project Agency, known as EUSPA. And the others are GLONASS, which is the Russian, Beidou, which is the Chinese, and XZR, which is the Japanese, and then we have the latest to join the GNSS collective, and that's from India, and it's called Navic. So each one of these constellations operate on a slightly different frequency, and it typically ranges from about 1 gigahertz through to about 1.6. However, I would say that Navic is operating at the very upper end, up around 2.5 gigahertz. So there is a little bit of a clustering, but now it's stretched out because of Navic. So you can imagine, and I'll give you another very important reference point here that illustrates why it's so difficult to have complete sovereignty around these constellations. Galileo, and each constellation circumnavigates the Earth other than the Japanese, and it kind of goes in a figure eight over the country of Japan. But for the most part, these constellations are available globally. And as a result of that, Galileo had in excess of 4 billion users last year. That's 4 billion connections from devices on the planet to the European constellation. Um, so there aren't 4 billion people in Europe. So that'll give you an idea of how globalized even the satellite services are, and the proliferation that it results from consumer devices becoming more connected, and more device, not just consumer. In fact, every segment in the industry somehow now wants a location device,
Mm-hmm.
whether it's for positioning, velocity, or timing. It seems that everything needs GNSS nowadays. So, how do you legislate for that? How do you govern for it? Or how do you create a sovereign stack from consumer to the satellites in space? How do you do that? It's a very difficult question to answer, and I don't think it's possible, quite frankly, other than in the case of it being policed, where connectivity can be controlled by a government if it wants to be.
So what do you think is, driving this shift from GNSS being treated as a global utility to now being considered with more sovereignty and control?
Well, I think the geopolitical stressors that we're living through at the moment amplifies a lot of paranoia and fear, and a lot of that, of course, is real,
Yeah.
and grounded in reality. And there's a retrenchment across the board in all aspects of our life. So the fact that um, we we're so dependent upon GNSS for day-to-day life and for innovation, protecting the authenticity and the reliability of a sovereign constellation is in the interests of the citizens of that sovereign territory. And it just what I believe drives it is the the paranoia resulting from these geopolitical issues, so that you can ensure the safety and security of your sovereign infrastructure,
Mhm.
and the citizens, and again the innovation economy, and make sure that your geographical location continues to have a virtuous cycle that or circle that is not unduly threatened by bad actors, and those bad actors come in the guise of spoofing. Typically, when we talk about GNSS, and a spoofed signal is basically a signal from a satellite, GNSS satellite that's hijacked, and it is then spoofed, which means it's the user believes that they have an authentic signal, but the bad actor is guiding them to um, a destination other than the original uh, destination, and therefore they want to either hijack them or rob them or do something bad. That's the ultimate price that people pay in such a situation.
Mhm.
Um, and of course, the governments want to protect their citizens from that type of an impact, and therefore, having a sovereign GNSS stack is in their interests. From our perspective here at the company, at Qualinx, um, our underlying technology is based on a mechanism that switches very quickly between the acquired signals, or those signals, radio signals that are available, whether it's GNSS or ground-based sources of location data, and that might be IoT gateways or some other ground-based stations. But our technology has an intrinsic switching capability that will allow you to either deterministically select which sources of your it's called PVT, position, velocity, and timing signal. The sources of those signals are authentic or not. So you can deterministically select which ones you want, or you can have some form of sensor fusion where there are trigger events that will determine what signals you want to acquire and how you want to authenticate those. And unlike most of our competitors or the legacy technology in the industry, which is purely analog based from the receiver perspective, um, we can deliver that agility and versatility in a single chip solution. And not only that, it because it's based on digital RF, the chip has all the benefits of CMOS scaling, and the most tangible benefit is the power envelope. And we are in consumer devices anywhere from 5 to 20 times lower power consuming compared to legacy solutions in the market.
Awesome. Yeah. Speaking of Qualinx's technology and, chips, I kind of wanted to talk more about the QLX 3GX series
Yeah.
that highlights ultra low power and high performance GNSS. And I believe you even touched on this a little bit, but what really differentiates your approach from conventional GNSS chip architectures with this technology?
Yeah, just you're right there. Just continuing from um, the prior comments I made, the underlying novelty is called digital RF, and essentially we transition 90% of a legacy analog-based RF radio receiver to digital CMOS. Um, Analog in terms of GNSS is hitting the scaling wall and can't really keep up with Moore's law any longer. Um, and it just taps out. It's not the first technology to hit a scaling wall, and it won't be the last either. But our invention, our novelty, allows us to bring RF back in line with Moore's law. So there's a structural and a generational advantage that our company has that we can pass downstream to our customers. And as you know, with CMOS scaling, you you continuously gain performance and power advantages as you shrink through in line with Moore's law, essentially. So that type of capability in the chip, specifically shrinking transistors and therefore gaining intrinsically lower power with increased performance over time, enables a downstream cycle of innovation that's not currently possible. Um, there are um, two ways by which Qualinx's chip empowers the downstream customers to innovate. And firstly, it's simply because of the performance, power, and the physical size. And there are cost benefits, of course, all the way through. But you that plowback from those benefits, it directly impacts the device. And again, the easiest example is to talk about power, because it translates directly to battery life, and that then becomes quite an important differentiator for our customers in their own markets. And we can extend battery life, like I mentioned a few minutes ago, by anything from 5 to 20 times. The second very tangible benefit of the scaling effect is our ability, the digital scaling effect, to be more precise, is our ability to integrate some of the peripheral components from the system. And that could be a wearable, such as a watch, or a navigation device for e-mobility and so forth. It could be a range of different applications, but we can integrate peripheral components that are currently off chip, and we move those on chip, allowing a the ability for our customers to free up space or have better thermal flow and eliminate fans or cooling or heat sinks, or and ultimately allow them to either adjust their form factor, or to replace that empty space that we have freed up with other components, and increase the overall performance and attractiveness and differentiation of that end product for themselves. So there's a total cost of ownership benefit that impacts all the way downstream to the end user. And we also like to talk a little bit about the impact that we have on the environment. If you project out and extrapolate the elimination of batteries, or the reduction of battery size, or the elongation of battery duration, we have the potential to take tens of thousands of tons of CO2 out of the air every year.
Wow. I mean, you mentioned a bit about wearables. There's a demand to reduce the drain of positioning and tracking and wearables and IoT and things like that. In your opinion, why has GNSS historically been so power hungry, and how does your solution, the QLX G3X, approach this demand?
hmm It's interesting because I think as edge nodes and wearables, basically battery powered devices, as they've proliferated, the power consumption of analog has been exposed more and more. And
Mhm.
it's, you know, years ago, it wasn't such a big consideration because you weren't battery dependent. We really didn't suffer from this sort of range anxiety or battery life anxiety that we all do today. So I think that that has exposed the ultimate weakness of an analog based GNSS solution. That's one thing. Maybe that's just perception, the eye of the beholder, etc. But what's very scientific is the fact that physics just mm, uh, means that analog cannot scale efficiently or economically beyond a certain point. We're going to market at 22 nanometer today, and the majority of our peer competitors in this space are on nodes that are older, and bigger and more power hungry than we are. So we see an industry built around analog RF that's hitting the scaling wall, and our the legacy solutions are um, running into these physics barriers, and that just doesn't make it economical for the supply base to shrink. Um, that's our point of entry. So we think we can um, break the the pain the pain points of analog power, and fuel the cycle of innovation downstream because of those benefits that are born out of the fact that we're scalable. CMOS scalable.
Awesome. Um, I wanted to talk a bit more about your collaboration with the European Union Agency for the Space Program, and what integrating the Galileo Open Service Navigation Message Authentication protocols mean for secure GNSS deployments.
Yeah. So USPA, the European Union Space Project Agency, is responsible for managing the services that are delivered from the Galileo constellation, and they're
Mhm.
available worldwide. And we talked a few minutes ago about 4 billion users
Yeah.
connecting at any in one period last year. Um, the the Galileo constellation offers a host of services. There's an emergency response service, there's a high precision service, and there's the OSNMA service, which essentially is an authenticator to ensure that the signal your device receives is not spoofed, that it is an authentic signal from a Galileo satellite. Now, we're we were very, very fortunate because we were in the middle of our hardware design cycle. So we had the opportunity to truly embed the service into our chip, and it became a workflow alongside some of the other workflows for the development of our QLX 3G series. And unlike what typically happens, where you already have an existing hardware, an existing receiver or semiconductor in production, and then you just um, implement software that sits on top. And that's great, but I think the fact that we embedded it and tuned some of our hardware to optimize for the OSNMA service, for this authentication service, complements some of the other hardware differentiators we have to ensure our chip is more resilient to spoofers.
Mhm.
And it does so in a very complementary way that does not um, impact the performance or increase the power envelope, and yet gives us the ability to deliver a single chip with that class of resilience to every segment, whether it's an edge node, a wearable, or high precision farming equipment or mining equipment, and so forth. We don't discriminate or differentiate between the end application, and every application gets that same enterprise grade or space grade, if you like, authenticity and security.
Mhm.
And at the end of the day, that translates directly to safety and security for our customers because they can be assured that their signal from a Galileo satellite with an OSNMA service on a receiver like ours operating in a super ultra low power mode is as secure as it can be.
Awesome. Kind of just looking towards the future now, as GNSS becomes more critical to infrastructure and autonomy, how do you foresee this concept of sovereignty evolving over the next, couple of years?
Um, So as we look out 5 to 10 years, one of the the signals that we're getting from our own customer base is that the level of authentication that was previously reserved for or priced for the very, very high end and high performing applications will have to become the standard. And the capabilities of GNSS receivers have to be versatile and agile enough to understand the switching capabilities between constellations. And there's a an operational overhead that I think is going to be critical insofar as ensuring, firstly, innovation and then secondly, affordability for end users. If if suppliers have to create and build very separate um, versions of their chips to serve geographies, there's a proliferation in the supply chain, and there's an inflation in the overall operating expenses of the suppliers in order to do that. And we all know that the the results of COVID and the impact it had on the supply chain um, were really dramatic, and we're still feeling there's still a little bit of a hangover from that in the system. So creating a scenario where we distort the supply chains and inflate the costs just doesn't help the system at all. It doesn't help anybody in the value chain or the supply chain. And ultimately, the end user pays the price. So I do have some fear around that the bigger impact and the downstream effect overall. But from Qualinx's perspective, we're very insulated from the the overhead and the burden that might be caused by a proliferation in manufacturing and different SKUs that we have to target for different regions because our chip is ultimately reconfigurable. Um, and that is enabled by the architecture itself. Now, that means we can service any application anywhere in the world and configure that for its not only its purpose but its actual location. And the versatility of the the chip, insofar as its reconfigurability, allows our customers to uh, postpone the configuration of their end device until they ship it to a specific application, user, or geography. So we're enabling a downstream uh, efficiency for our customers. So not only do we take cost and complexity out of our supply chain, we allow our customers to do the same thing. And the ultimate winner is the end user, in that scenario, because there isn't an inflation effect. In fact, it's the opposite with the removal of cost and complexity. And then the end user benefits from a hopefully a lower price. Hopefully, our efficiencies and total cost of ownership translates to a lower price for the end user and better innovation.
Amazing. Wow. Um, Tom, I believe those are all the questions I have for you today, but as always, I like to ask if there's anything I might have missed or anything else you'd like to add.
Yeah, thanks, Tiara. Yeah, I appreciate the time you've spent with us here. Um, we're about to launch into manufacturing, and we have a full 100% onshore European supply chain. Um, but we don't view that through the sovereignty lens. Of course, it's an important lens, but we're trusted globally. And and I do think that companies that such as ourselves who employ a um, or look at their supply chain through the sovereignty lens are looking at it much more broadly than just the sovereignty argument. They're looking at it from an efficiency perspective and a de-risking of the overall supply chain, not just a geographically based sovereign driven um, philosophy. So if the outcome of the debate around sovereignty results in more efficient supply chains and the de-risking of supply chains and an avoidance of what we went through back in the COVID era, well then, it's going to serve us all very, very well.
Well, thank you, Tom, for joining me on the podcast today. I'll just advise everyone listening to check out the description of this podcast and get more information on the company and
Thank you too. I appreciate it. Appreciate the opportunity to introduce Qualings a little bit to you and to your listeners. Thanks so much, Thea.
Now, here's Rod Cope of Perforce Software.
Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Nass. I am with Embedded Computing Design. This week's guest is Rod Cope, the CTO, Chief Technical Officer at Perforce Software. How you doing, Rod?
I'm good. How are you, Rich?
I'm doing just great. Thank you very much. So you're in a unique position to answer some of these questions that I keep asking people about the use of AI in code generation. There seems to be a pretty much of a consensus that we should not be using AI, artificial intelligence, to write our code. However, there are some people, and I'll see where you fall on this, who think it's fine and should be used for the review of that code. Do you agree with both things or either things or neither thing?
I actually agree with both. I think not only is it okay to use, I think we have to use it in order to compete. To keep up with technology, to keep up with the competition, we got to use it to go much faster than we ever have before. So I think we have to use AI to generate the code and then different AI to review the code. If we have kind of the same AI generate and review it, it's kind of like the fox watching over the chickens, right? So I like to use multiple models when I can to make sure they double check each other.
Okay, I find that pretty interesting because most of the people I spoke to say it's not okay to use AI to generate the code originally because at least right now or over the last few months, the code that has been generated has been pretty bad. Are you seeing that it's different?
I think it's improved dramatically just in the last few months and even weeks. It seems like we're at the tipping point where the models have become good enough, and now they're starting to become as good as, if not better than, developers in a lot of cases. So of course your use case makes a big difference, but in a lot of environments, yeah, that with the most recent batch of models, now we have Opus 4.7 and we have OpenAI and ChatGPT 5.5 that just came out, and they're big steps forward. So I think it's a good time to reevaluate if people have been in the, hey, it's not good enough, or it's writing bad code or insecure code or impossible to read code or whatever. I would give it another shot.
That's really interesting. At some point, does the code have to be reviewed by a human before it's released?
I think today, yes, but I also see that changing pretty rapidly. Part of the reason is that now you've got multiple models from competing vendors that are pretty much on par with each other, that are very good. So I can have one model write code, I can have it review its own code, I can have it write adversarial tests to try to attack its own code. And then when I get comfortable with it, I can hand it to another model and say, hey, there's hidden vulnerabilities in this code, find it. It kind of tease the other model, or even, this is kind of funny, if you tell the second model that its competitor model wrote code, it will actually be more aggressive and find more bugs, which I find pretty funny. If you tell it wrote the code, it'll be like, no, this looks good. Oh, a competitor wrote it. Oh yeah, this is horrible. Let me tell you all the things wrong with it.
That's really interesting. Many years ago, I guess I'll date myself, in the people who were developing hardware, there were lots more hardware engineers on the team than there were software engineers. And then over time, that seemed to change, that even at a hardware vendor, there were far more software engineers than hardware engineers. Will AI shift that back, that we don't need as many software engineers and there'll be more hardware people on the team than software?
That's a really good question. I think maybe a scary answer, but I think there'll be AI everywhere. So I think there'll be AI designing chips and communication devices and networking equipment and everything, in addition to the software. It'll be, I kind of think of it like a power tool, right? You could still use a hammer to pound in all the nails, but if you had a pneumatic nail gun, you can go a lot faster no matter what the job is. I think the AI just brings us a whole new set of tools to that tool bag, and it's, you got to know how to use them. You need to practice. You need to train with them. You need to know what they're good at and bad at. But they're just more tools. And so if you're an experienced worker of any kind of knowledge work, and you know how to use a bunch of tools, now you have more good stuff to reach for. And a lot of times you're going to find yourself reaching more and more for the advanced AI over time as they work out the kinks and reduce the hallucinations and that kind of thing. But that's happening week after week, month after month. So it's a good time to find another tool that fits in your bag.
But an elephant just popped up in this room here. If I'm a software engineer working on your team, should I be concerned about my job?
I think anybody doing knowledge work has to be a bit concerned, right? If you don't adapt. I think if you are willing to change, and that's hard. Change is hard. I don't want to make that sound easy in any way. It's easier to learn something new from scratch than it is to change something you already know how to do well. And I think that's going to be a struggle for a lot of people, is to say, okay, AI doesn't replace me, but it means I have to do things differently. So instead of, I'll pick on a software developer role, instead of writing the code line by line, and that's my identity. I've been doing this for decades. Like, okay, this is me. Now I have to suddenly step away from the keyboard and be more concerned about supplying constraints and requirements and specs and I didn't mean that, or I know what I like when I see it. Now I see it. Okay, here's what's good, here's what's bad. I become a reviewer. I become an editor, an approver, a director, and not the guy with the hands on the keyboard writing the code. So still very valuable. Human judgment is even more critical than it's ever been, because without that, if you just say yes to anything that AI comes up with, you're going to get a mountain of garbage very quickly. So that judgment is still absolutely necessary, but it does change what people do day to day and how they think about themselves and their role. So people who are willing to make that change and to skill up, or hopefully their employer is helping them do that, they're going to be fine for quite a while. People who don't and say no, I'm going to dig in my heels and say AI is bad, or it's not good enough for this job, or it writes bad code, whatever. You've got a short window where that's going to be true, and then you're going to be challenged to find the similar work that the AI can do easily.
Does it produce better products or similar products faster?
I think a little bit of both. I think again, go back to that nail gun analogy. You can you can put in 1,000 times more nails in a day, but if you put them all in the wrong place, it doesn't help very much. So if you know what you're doing and you know where to put the nails, now you can go much faster. In theory, you could also say, well, I can build a better house because maybe I put more nails where they need to go, and I have a better quality house as a result, versus if I had to hammer them in, I might skip a few here and there.
Yep.
I do think that's also true with AI. You can get better tests, potentially better security. There's lots of things you can nail down better now when you can just say, yeah, go do that. And it just costs me some money and time. And the AI does it versus, oh man, I got to slog through this thing for 3 hours just to do the right thing here and get a 1% better result.
Are you surprised by the speed with which AI has entered the engineering lab?
Yes. It's kind of funny because I'm a guy who's always ahead of the curve and predicting things too early. I've done that most of my career. And in 2016, I did a future talk where I kind of predicted, pat myself on the back, as best results I've ever had. I really predicted everything that was going to happen last year and this year with AI. But it came up fast all of a sudden. Like, it seems like 2 years ago, and like, oh, these are wild predictions. They're never going to come true. Now it's like, oh, maybe I undershot. It seems like we hit the exponential of the curve, and it just skyrocketed in the last 2 years and even the last few months. And it's very hard to predict 10 years out. I'm not even trying much anymore. It's so hard to foresee that far ahead with where we are. But yeah, it kind of snuck up on, I think, on everybody of just how fast it got here. Even though we kind of all knew it was coming eventually, it's like you wake up one morning, it's like, oh, it's here.
Yep. Do you think that Perforce is embracing it as well as competitors, better than competitors, not as well as competitors?
I think we're ahead of the curve in some areas, like on our testing side, our testing products. We've really embraced advanced AI and natural language and autonomous systems, and we're really ahead of the curve there. And we have opportunities in other areas where we're not as far. I guess I'd say we haven't gone down that transformative road as much. It's more like we have AI features and incremental improvements. But in a couple key areas, synthetic data generation, infrastructure automation, and testing, we've really embraced the, hey, there's a completely new way to do this stuff, given where AI can go. We don't have to just speed up a process we already have. We can think about taking steps out or making entirely new processes, viable that streamline everything.
Normally at this point in the interview, I ask what you think the world will be like in 2 years, but we don't even know what it's going to be like next month. That's probably not even a fair question.
It's a tough one. If I had to look forward 2 years, I would say companies that are kind of saying, well, show me the ROI. I spent a bunch of money on AI. I'm not really seeing those results, or I have people tell me there's too many hallucinations and issues. I think they will probably continue to say those things, but they're on a clock, and at some point, their competition who has embraced it and said, you know what, this changes the game. It changes the work we do, but also how we're organized as a company, how we think about products and market fit, how we test, you name it, across the board. Those competitors 2 years from now will be moving 10 times faster. And when they bring something to market that's very advanced and futuristic, those first companies that have been trying to pretend this isn't happening are going to be in real trouble. And I think we're going to see absolutely that. We're going to see both. And the bigger enterprises and companies, they've been around a long time, have a lot of customers, a lot of products. They'll maybe feel safer than they should if they go down that route. So what I'm trying to say is, don't be an ostrich when it comes to this. Make the investments, do the experiments, because your competition is. You don't want to be left behind.
I couldn't agree more. Thank you very much, Rod. This is really fascinating, as much or more so than anything that I've covered in my time.
Yeah, thanks, Rich. I can say the same. May we live in interesting times. Has never been truer.
Yeah, that's for sure. That was Rod Cope. He is the CTO of Perforce Software, and I'm Rich Nass with Embedded Computing Design.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.